Now, today our topic is introduction to limits. What is a limit? The limit of a function describes the behavior of the functions as the input approaches a particular value. Notation: limit x tends to a f of x equal to L. This means as x gets closer to a, f of x gets closer to L. Example: limit x tends to 2 x square plus 3. Now we will simplify this example, then we get 7 answer. Because when x is near to x square plus 3 is near 7. Left hand and right hand limit. Left hand limit approach from left, limit x tends to minus f of x. Right hand limit approach from right. Now limit x tends plus f of x. A limit exists only if limit x tends to minus f of x equal to limit x tends to a power plus f of x equal to L. Example: f of x equal to 1 and 2. X less than 0. If 1 is given, then x less than 0. If 2 is given, then x greater than equal to 0. Now we simplify. You can see here limit x tends left hand side limit. Left hand side limit means x less than 0, we use 1. Same passes if we find the limit in right hand side. Now you can see here x greater than equal to 0. It means right side equal to 2. So limit does not exist at x equal to 0. Now you can see here theorems of limits. Limit x tends to a f of x equal to L. Limit x tends to a g of x equal to m. Now you can see here some rule of the limit and same difference rule of the limit is given. Ordered rule of the limit is given. Quotient rule of the limit is given. Constant multiple. Now you can see here if here is given constant, then we can get limit form. Some useful standard limits. These are essential for evaluating difficult limits. Limit x tends to a sin x upon x equal to 1. Limit x tends to 0, 1 minus cos x upon x square equal to 1 upon 2. These are also formula. You can see here some useful standard limits. If some limits are given in this form, then the value get 1, and in this form then value get 1 upon 2. If limit x tends to infinity, 1 plus 1 upon x exponent x equal to e. Limit x tends to 0, e power x minus 1 divided by x equal to 1. Now, finally, you can see limit x tends to 0 ln 1 plus x divided by x equal to 1. Application of limits. Defining continuity. A function is continuous at x equal to a if limit x tends to a f of x equal to f of a. Defining derivatives. F dash x means first derivative equal to limit x tends to 0 f of x plus h minus f of x divided by h. Physics. Instantaneous velocity is the limit of average velocity. Now you can see here application of limits, the formula of applications. Graphical understanding. Use graphs to show when left and right limits are equal, limit exists. When left and right limits differ, limit does not exist. A jump discontinuity. Summary. Limits describe the behavior of functions near a point. Left and right hand limit must match. Theorems helps simplify complex limit expressions. Standard limits are tools for solving tricky problems. Limits are essential in defining continuity and derivatives. Now you can see here, first you understand all formulas. After understand, you solve these questions. Here is given practice problem. Evaluate. Limit x tends to 1, x square minus 1 divided by x minus 1. Same process. Question 7 is given. Here is given left hand limit and right hand limit not equal to 0. Function is given. Now you solve also these questions. Third questions, use standard limits to find limit x tends to 0 and x divided by x. You must be remember first formulas. Then you solve step by step all the given questions in your paper. Okay, thank you.